Welcome back to today's session. Hope you people are at home and staying safe. So, in the previous class, we discussed about what is assignment problem and how do we formulate the assignment problem as a linear programming problem. Next, before going into the solution domain, I would like to discuss the categories of assignment problem. Assignment problem basically has four different types of problems. One is a balanced assignment problem in minimization case. Next one, unbalanced assignment problem in minimization case. Next, balanced assignment problem with maximization case and unbalanced assignment problem on maximization case. See, out of all these four, the natural way of solving or the standard way of solving assignment problem is the balanced assignment problem in the minimization case. So this is the standard form. Whenever you have any other three forms available, you will have to convert it to standard form and then only you will be able to solve the problem. So the procedure of solving an assignment problem is any category of problem is given, it has to be converted to the standard form, that is balanced assignment problem in minimization case. Why should we convert it into balanced assignment problem of minimization case? The concept is quite very simple. The solution procedure or the algorithm that we have defined to solve the problem is only for balanced assignment problem in minimization case. So whatever category of problem is given, we will have to convert it to standard form, and once it comes to standard form, you will be allowed to apply the algorithm or the procedure to solve the problem and arrive at the solution. Now let us discuss the algorithm for solving assignment problem. So the assignment that or the algorithm that we have implemented for solving assignment problem is called Hungarian algorithm or Hungarian method. So step one of this algorithm says if the problem is in maximization case, convert it into minimization case. If it is in minimization, retain it as it is. So the first step is to compare whether it is maximization or minimization. If it is minimization, retain it as it is. If it is maximization, then we will have to convert it to minimization type and then go ahead. So the first priority is always given to conversion of maximization to minimization. Then, if the problem is not balanced, when do we call an assignment problem to be balanced? The problem is said to be balanced if the cost matrix given is a square matrix. That is, the number of rows is equal to number of columns. If the number of rows and number of columns does not match, then it is called an unbalanced assignment problem. Why should it be balanced? Because the assumption of assignment problem that we have seen during the definition of assignment problem is that the number of workers should be equal to the number of jobs. Only then we will be able to assign one worker for each job and one job for each worker. Therefore, the number of workers and number of jobs should be equal. In other words, the same thing can be said as the number of rows should be equal to the number of columns. So if the problem is not balanced, how do we solve it? We will have to balance it. How to balance it? Add a dummy row or dummy column as needed with cost values being 0. See if the rows is less, if at all I have one row less, then add one dummy row. If one column is less, then add one dummy column. So whichever is less, we will have to add a dummy row or a dummy column as needed. And whenever I add a row or a column, for that particular row or column, the values will not be given. So I need to go with an assumption that the cost for such dummy row or dummy column will be zeros. Fine. Hope the step 2 is also clear. We'll go to step 3. The step 3 says once you have a cost matrix, for each row, identify the minimum element of that particular row. Right? Identify the minimum cost element of that particular row and subtract that value from all the remaining elements of the row. This is called row reduction. So I'll read out. Choose the minimum in every row and subtract this from the rest in that particular row. Then repeat this for all the rows, not only for the first row, but for every row. I am supposed to pick the smallest value in that particular row and subtract that from the remaining elements of that particular row. This is called row reduction. Why do we perform row reduction? Because for an allocation procedure to be made, we require zeros in the cost matrix. See, in the given problem, we may or may not have zero in every row and every column. So I want to induce a zero in every row and every column of the problem. So how do I induce a zero? For that, I will be performing row reduction first and then column reduction. So once I perform row reduction, every row will have at least one zero. So every row has a zero, but we are not sure whether every column has a zero. So to ensure that every column also has a zero, we go with step 4. In the step 4, same procedure is done, but with respect to columns. For every column, I pick the minimum most element and subtract that from the corresponding column and write. So I'll just read out now. Choose the minimum in every column and subtract this from the rest in that column. Repeat for all the columns. The same procedure we are doing, whatever we did for row, the same procedure we are just following for the columns. Now you have a doubt. If at all the column has the minimum element as 0, what to do? If the column already has a 0, what to do? Consider 0 as the minimum element. Right? The concept is very simple. Consider the column minimum to be 0 and subtract 0 from the remaining elements of the same column so that the remaining column elements will remain the same. So we need not bother. If at all you have a non-zero, you will be subtracting it. If at all it is a 0, if you subtract a 0, the values remain the same. So it doesn't matter. So we will have to perform row reduction to ensure that every row has a 0. Then we perform column reduction. We ensure that all the columns also have 0. By the end of step 4, every row and every column in the problem will have at least one 0 available. So once we have done with that, next we go to step number 5, which is called allocation step. Right? Step 3 is called row reduction step. Step 4 is called column reduction step. Step 5 is called allocation step. So how do we perform the allocation? Choose a row or column which has only one 0. Right? Choose the row or the column which has only one 0 and put a box. Whenever we write a box, it is called an allocation. So put a box to that particular 0. If at all you don't have a single 0 in any row or any column, then the next minimum will be 2. So out of the 2, any one 0 you mark it as allocation, and any other zeros in the same row and the same column, we just have to cross it off or cancel it. Right? If we have only one 0, then cancelling will not arise. But if you have more than one 0, then one of the zeros will be allocated and the remaining zeros in the same row or same column will be cancelled or will be crossed out. This process will be continued till all the allocations are made. What do you mean by all the allocations are made? We would have a certain number of zeros in the problem. So all zeros should be containing either a box, that is the allocation, or it should be cancelled. So till all zeros are covered either by a box or by a cross, we will continue this procedure. So this is called allocation procedure. So if at all I had 4 workers and 4 jobs, how many allocations I should have? So obviously I need to have 4 allocations. See, when I performed the allocation step, I might not have got 4 allocations. I might have got only 3 allocations. Remaining zeros might have got cancelled. So that means to say I have not yet arrived at the answer. Right? I have not yet arrived at the answer. In that case, go to step 6. If the answer is not obtained, draw horizontal or vertical or both lines to cover all zeros. So we are supposed to see to it that all the zeros that we had in the problem in the cost matrix will be covered under the lines. So how do we draw the lines? For drawing lines also we have a certain procedure or a method that has been defined that we will see in the next slide. So the number of lines must be equal to the number of allocations made. How many ever allocations you have made, the same number of lines you would get. So now we will look at the procedure for drawing the lines. So to draw lines, put a tick mark on the row which does not have assignments. So how do we draw lines? For this the procedure is defined. So look at all the rows. Whichever row does not have an assignment or an allocation, for that particular row put a tick. And in that ticked row, whichever column has zeros, right? Whichever column has zeros in this ticked row, for that corresponding column also put a tick mark. Once again, I'm repeating. Tick the row which does not have assignments. In that ticked row, whichever column has a zero, it might be a crossed zero, right? So whichever column has a zero, tick that particular column. So this is the first step. The second step is put a tick on the row which contains assignment in the ticked column. So I tick the column in the first step. So in that particular column, we need to check if at all there is any allocation in any of the rows, then that particular row has to be ticked. Fine. Tick the rows which contains assignment in the ticked columns. This is the second step. So now certain number of rows and certain number of columns are ticked. Now we are supposed to draw the lines. How to draw the lines? The procedure says, now draw lines through the ticked columns and then from the unticked rows. So whichever are the ticked columns, for that we will draw vertical lines, and for the rows which are not ticked, we will put horizontal lines. So when we put such lines, all the zeros that we had, will be covered under the lines, right? The zeros will be covered under the lines. After covering all the zeros under the line, now we come back to step 7. So what does step 7 tell us? Choose the minimum number not covered by the lines. See, when we have drawn lines, all the zeros are covered, but there are still numbers which are not covered under the line. Right? There might be elements which are not covered under the line. So out of those numbers which are not collected under the line, choose the minimum most number. Fine? Choose the minimum most number. Subtract that number from the remaining uncovered elements. Out of all the remaining uncovered elements, subtract this value. Fine? And not only subtracting it from all uncovered elements, but this number has to be added to the point of intersection. See, whenever we draw horizontal lines and vertical lines, there is an intersection that happens for the horizontal and vertical lines. Wherever you have an intersection where the lines are crossed, under those places, under that intersection, whatever number you have, to that number we will add the smallest number that we have identified. So that gives rise to a new cost matrix, right? Altogether, I have got a new cost matrix now. So when I get a new cost matrix, the same procedure of row reduction, column reduction, allocation, if not obtained the answer, then drawing lines, and after drawing lines, finding the minimum uncovered element, subtracting it from uncovered elements and adding it to the point of intersections. This procedure will repeat. So we keep repeating this steps 3, 4, 5, 6 and 7 until we get the expected answer. What is the expected answer? The number of allocations that you get should be equal to either the number of rows or number of columns, right? The number of assignments should be equal to the number of rows or number of columns. That is what we expect as the output of the assignment problem. Then what we do is, wherever we had an allocation from the original problem, we take the cost, add it up, that will give us the total assignment cost, which will be minimum. Fine. This is how assignment problem is solved. In the next session, let us consider a problem and see how this particular algorithm is implemented to solve the problem. Hope you people have understood the algorithm. One thing that I expect from you is, before I start solving the problem, I want you people to go through the algorithm at least 2 or 3 times, so that when I am solving a problem, you will also be able to understand what are the steps I am following. Fine? I expect you people to go through the algorithm before I solve the problem. Thank you for your patient listening. Have a nice time. Enjoy. Bye.